Hi everybody, let us discuss about how to retrieve an element at a position in a doubly linked list. So the input for this operation will be a list and the position where we want to retrieve the element. So if we are given a doubly linked list like this, and if I give the position as 4, I want to return element 45. And the boundary conditions that I have to handle are position may not be valid in certain cases. Totally there are 5 nodes here. Suppose if I am giving the position as 6 or 7, then in that case I have to communicate failure to the callee function. When we look at the communication way, we are going to return an element, right? In the doubly linked list, the data can also be negative. There is no guarantee that there will not be negative data or there will not be -1 as data, right? So we cannot return simply -1. Instead, for communicating to the callee function, we should have a means like having a global error flag. Okay, and the boundary conditions, other boundary conditions that we have to consider are if the list is empty, then in that case also we have to return failure. Okay, so same thing, we will set the global error flag and return -1. So let's formally write the algorithm. If the list is empty, then we have to communicate failure, return -1, otherwise declare a temporary pointer and integer counter. Okay, so that's how we are going to basically do, isn't it? So we will be having a temp and then we'll be having a counter equal to 1, right? And you'll be checking whether counter equal to position. If counter becomes equal to position, then you'll be returning the data part of node pointed by temp. Otherwise you'll be moving temp to the next node and incrementing the counter. That's all. So the same thing, we are initializing temp to point to the first node and counter to 1. When counter is less than position, we have to repeat step number 5 and 6. If temp is tail, right? That is, if we have reached the last node, then we have to move. If temp is tail, we will simply break, right? This is the case when we have got position greater than the number of nodes, right? So if there are 5 nodes and I have given the position as 6, then we have to do this. Otherwise what you are going to do, move temp to the next node and increment the counter. If position equal to counter, then we are returning the data part of temp and we are returning communicating failure otherwise. Okay, so we may have, I think we have to check here if temp is null, that is if the temporary pointer moves outside the list, right? Should not be tail, should be null. So we will check during the implementation. Let's implement this algorithm. So retrieve function is declared. Before that we have declared a error flag. Global declaration is done using extern keyword, and then I have declared the function and I have passed the list by value. It's sufficient, and then the position is also passed. Now let's look at the retrieve function we will implement, right? So here I have to have a temporary pointer and then I have to have a counter, then I have to reset the flag, right? So I will tell retrieve error flag equal to 0 if the list is empty, if is empty of L, right? If the list is empty, then we are going to return communicate failure. How we will communicate failure is we have to tell retrieve error flag equal to 1 and then you have to return -1. Okay, otherwise you are going to initialize temp to the first node, right? Initialize temp to the first node. So you will say temp equal to L dot head, because we have passed it by value. You have to use dot operator, and you will be telling counter equal to 1. Okay, and while counter less than position. Okay, while counter less than position, if temp, if we have moved outside, right? If temp equal to null. I hope this will be the correct thing. If temp equal to null, then we have to break the loop, or we can return when we have moved outside, we can definitely return the error, isn't it? So how we can do is, we just make the retrieve error flag equal to 1 and we have to break. Okay, not break, better return -1. Okay, so this should be if temp is null, that is you have moved outside the list. Otherwise you will be moving temp to the next node, temp equal to temp next, and increment the counter if position equal to counter, right? This is the case when I am reaching the node correctly, right? So I'll be checking if position equal to counter, right? In that case I'll be returning the data part of the node pointed by temp, right? So I can tell return temp data, and you have to communicate error, otherwise retrieve error flag equal to -1, right? And you can tell return -1. This error flag should be 1, should be set, we should set it. Okay, and let's see the main. I have just called the retrieve function with 1 as the position, and I have to check here the retrieve error flag equal to 1, or I can simply check like this. If retrieve error flag, then I will tell error or something like that, error. Otherwise I'll be telling element at position is, right? Okay, so I can check like this. So let's compile the code and check it. Yeah, few errors are there, and retrieve 258. Let's check it. 258. Yes, I missed a brace. So 286. 286. I think one brace is missed. Yes, while. Okay, I have to finish while after this. Okay, yeah, done. Let's check it. Yeah, element is at position 1. Okay, element at position is 1. I have my position and the element are same. I have given here retrieve the element at 1, then next try for 2, element is 2, and 3. Let me change the element and show otherwise. Let me say 37. Yes, element is 37. You can see that. And if I am giving a retrieve at element position 4, it should not work. Let's see. Oh, I am getting segmentation fault. Yeah, 1 minute. Maybe I think I confused here. I was making a change while I think here may be the problem. Maybe I have to say temp equal to l.tail. Let me check this. L.tail, then simply break it. Okay, right, because that's what I wrote first. Let us check it. Yeah, yes, so the algorithm which we discussed first was correct. So if you are at the last node, right, if you are at the last node, then you have to break it simply, and that will be taken care here. Your position will not be equal to counter. That's how it will be taken care. that is what I'm trying to tell is, if the position where you want to delete it 6, there are only 5 nodes, right? When you reach the last node, you will break the loop, but when you come outside, your position is 6, but your counter will be only 5. So this will not happen. Instead, error will be returned, right? So this is the correct thing that we have to do, because in the next line we are telling temp equal to temp next. So only we got segmentation fault. When we tell temp equal to null, actually we didn't break. Maybe that was the problem. Okay. So the code will be shared in the GitHub. Thank you.